So just like we've used composite shapes previously to cut up shapes into things that we can work with, we can do the same with solids. So we've got a solid three-dimensional shape here, and we want to find the volume. Now it's an odd shape, one that we haven't really come across, so we can use the idea of composites to break it into pieces that we can work with. So I'm going to take this dotted line, I'm going to imagine if I had a saw and I just chopped off the triangular piece on the end there, I'd end up with two pieces that look like this. Now these two I can work with. This is a rectangular prism, and this one is a triangular prism. And we have previously worked out how we can work out the volumes of those. Let's call this piece 1, and we can work out the volume by looking at the dimensions, which we've just simply taken from our previous shape here. So a height of 3.21, 8 meters across the width here, and the depth being 2 meters. And shape 2, the dimensions has the same depth along here. We know it's got the same height as 3.2. Now this bit though, the length along here, we have to calculate, and it is the full distance here, which is 12 meters, take away this bit. So what we're left over with is this bit here at the bottom, and we can calculate that out to be 4 meters. Now we've got everything we need. We're going to work them out in two separate pieces. First piece, we're going to do this block 1. The volume is the length times the breadth times the depth. There are the numbers that I simply take from the diagram, and that works out to be 51.2, but don't forget it's volume, so it will be cubic. Our answer, or our units, will be cubed, and in this case we're working with meters. Now we can go ahead and work out the volume of the second piece, piece number 2. We take the area of the triangular face, which is half times base times the height, and then multiply it by the depth, will give me a value of 12.